I really like number 19. Number 19 is a cleverly disguised problem. So I'm not going to tell you the skill until the end, and we'll see if we can figure it out. Jamal is driving at a constant rate of speed. There's my first clue. On an interstate highway. When he reached mile marker 20, he began recording his travel time in hours. He recorded his travel time at other mile markers along the route. So I am going to graph Jamal's progress here, and I just need the top right quadrant, the first quadrant of a coordinate graph. And we are graphing miles per hour. Hour is the independent variable. That's the one that Jamal can control, how many hours he's going to drive. And we have this marked from 0, there's 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and I'll go ahead and put 6 down. We don't need it, but we can make it look nice. And then we're plotting the miles. Okay, so I'm going to go ahead and mark these off every line because we have quite a substantial amount of miles to cover. And then I'm going to go ahead and plot what it's telling me. So at 0 hours, he started tracking his speed. He had traveled 20 miles before he started this process. So the first point on this graph is 0, 20. This is the y-intercept. And if you were writing this as a function, this would be your y-intercept. It would be that number trailing on the end. Then at 2 hours, we have him traveling 150 miles. And then at 5 hours, we have him traveling 345 miles. So when I go to plot those, this is missing. I don't really know how to scale those miles. I don't know how to scale that y-axis. And that's a clue to this problem. That's a clue to the solution of this problem. What I do not know is the slope. I don't know the rise over run to know how to graph this particular story. But I do know 2 points, right? I know this one and I know this one. So I can use those 2 points. Let me write them this way. 2 and 150. And then 5 and 345. And we're going to let this be x1. So this would be x2. Here's y1 and y2. And then I can calculate my slope. Remember, slope is always rise over run. So you're going to put the y's on top. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that will be, I'm going to get my calculator here. I don't do well with math in my head. Definitely on a test, I would rather use the calculator than risk missing the problem. Now, if 195 will divide evenly by 3, and it will, we have a really nice thing going here. So 195 over 3 reduces to 65 over 1. So that tells me that he is traveling 65 miles per hour. I'm not going to go back and graph because that will just get us further into the weeds. You wouldn't have to see the graph at all. I just wanted to show you that that's one way I know I'm looking for slope, because I don't know how to scale that y-axis. Another way is constant rate of speed. The constant is a clue that we're looking for a slope. So how did we get the slope? What did we do to actually solve this problem? We had to use those points that we were given. And so I like answer C on this one. This problem was telling us indirectly to find the slope. And there is a whole chapter, I believe, designated for slope in this book. Maybe I'm wrong. I'm looking in the textbook. Okay. Oh, okay. Here we go. It's 5.1. Actually, I'm just going to call it chapter 5 because there is stuff about slope throughout that whole chapter. Again, this is in the Achieve book, Common Core Achieve. You are finding slope.